What's up? Welcome back. I hope you're enjoying the Advent of Code. In this episode, we're going to solve day 14 with Ruby for the Advent of Code in 2022. This one's called Regolith Reservoir. Regolith is like, or regolith, I don't know how you pronounce that. It's like sand or like a blanket of sand. And so we're still trying to communicate with the elves. And it turns out that we are in a cavern behind a waterfall. You can go read the story. This is the input we're going to receive. And this input describes some walls, and we're also going to have some air inside of this cavern, and then at a certain point, some sand that is pouring down inside of the cave that we're inside of. The way that these lines describe the walls is they are pairs of points. So we're going to go from 498, 4, down to 498, 6. So that is in the same column. We're going to draw a line right here. And then we're going to go from 498, 6 to 496, 6. So we're going to go from... We're going to draw that segment will draw like this line here. So each of these represents a wall. This one here is going to represent this wall. And then as sand pours down, it's going to fall all the way down to the bottom until it hits a wall or until it falls off. And as it falls down, if it lands on top of another piece of sand, it can go to the left or it can go to the right. And so if it falls and piles on top of a wall where there's space, then it can technically like fall off of the edge of the wall and land down below. So for the first part of the puzzle, what we need to do is parse out our lines into some data structure that we can use to describe the walls. The way that I think makes most sense for this is to have an array of arrays for each segment. So we're going to have an array that is 498.4 pointing at 498.6. Then we'll have a separate array from 498.6 to 496.6. And so we'll like group each of the pairs of segments so that we can go through and draw each of the parts of the lines into our grid. All right, so let's grab this input. Let's create a new variable called input, and we're going to set it equal to the value of a heredoc, where we'll just use input as our delimiters. We'll paste that in. The way that the heredoc works is you put the shovel operator with the squiggly line and then some starting marker and an ending marker that match. And then in between those two lines, you can basically create a multi-line string. And what's nice about that is we can work with a short string like this pretty simply. So let's run this and we get back this long string. Notice that it even has the new lines in there and everything. So now we can say input dot split on new line, and that'll give us two elements in an array. Now what we want to do is split each of these elements on an arrow. So we're going to say map split on the single pointer arrow thing, and now we should have a bunch of pairs. Okay, so now we have strings with these pairs of coordinates. This is like our X and Y coordinate. And now what we want to do is we further want to split these up by comma. So now we can map over this, and we're going to say that each line.map point.split.map to y. Let's see if this works. So this should split them up into, yep, so now we have integer values for each of the points. So here, let's break this up so it's a little bit easier to read. Now for each line, we want to combine each consecutive two elements. So after we've mapped the line, we can say dot each consecutive to dot 2a, and that will give us an array of arrays that should have each consecutive two elements in it. Okay, so now in the first line here, we're going from 498.4 to 498.6. And then that's like our first segment. Then our second segment is going to be 498.6, which is the same point as this one, to 496.6. What's nice about this is we can just iterate over each of these, and for our grid, we can draw them on the page. This is going to be our lines. Now, the first thing we want to do is figure out what the boundaries are for our grid. If we look at the example here, you'll notice that some of these points are really large, but when we're looking at the demonstrated output, this is like the 494th column, and this is the 503rd column. but we're really only seeing like a portion of the grid. So what I want to do is figure out what our boundaries are. So let's make a method called bounds that's going to take in lines, and this will return the like minimum row and maximum row, the minimum column and maximum column. And so what we want to do is go over our lines dot flat map do line, and then we want line dot flat map do point, or this is actually for each line we're going to get pairs of segments, and then each segment dot map first should give us the first element in each of these. So 498, 498, 499, etc., so on and so forth. So let's actually print out bounds. We'll say p bounds of lines and just see what we're getting back here. Okay, that looks good. From this set of numbers, we want to know what the min and max are. And there is a method called min max. So we can open up IRB here. If we have an array that has 1, 2, 3, 4, 5, maybe it has like -3 and 100, we can call .min max on this, and this gives us back a tuple or a pair where we get the minimum value and the maximum value back. So what we want to do is we have this first element, we're going to call min max on that, and that will give us back the min row and max row. And then we want to do the same thing, but for columns. So we're just going to change this to min column, max column, and we'll say this is the last segment. Okay. And then our bounds, what we want to do is return min row, min column, max column. And so let's just see if that works as expected. Okay. So we get 494 to 503 and then 4 to 9. So that's looking good. Now, in the example here, we don't actually use 4, like we don't go from 4 to 9, we go from 0 up to 9. So for now, we'll just like hard code minimum C as 0, and now we should get like 0 to 9 and 405 to, okay, so this is cool. All right, so the next thing I want to do is figure out how to build a grid from these boundaries. So let's make a lines to grid method that takes in our lines and also the bounds. Now, the goal here is to return a 2D array that is filled with air, and we'll say that the air is like these periods. Okay, so we're going to use our boundaries and we're going to split them up into min row, min column, max column, and that'll give us back a grid. And the grid is going to be based on, we want the columns. I think in order to make this work, we actually need to have this flipped. So this is going to be min C, so we max R, min R, and this will fill it with periods so that we get something, I don't know, something relatively reasonable. So we'll say our P lines to grid of lines and bounds. Okay, so let's see what we get here. All right, so that is giving us back a grid. Let's make a method that makes it nice to look at. So we'll just say display grid, and we'll print a new line, and then we'll say grid.eachDoRow puts row.join, and that should give us something nice. So this is going to give us back a grid, and we want to say display the grid. Okay, so now we have a grid that what we see in the example input. Cool. The next step is going to be to like actually add our lines to the grid. So as we're going through here, we need to iterate again over each of the lines, and then for each line, we're going to have a segment, and then each segment, we're going to have, so we're going to iterate from, so let's take this first segment. So as we're iterating over each segment, recall that that's going to have a start and an end, right? So we're going to have start and finish. We can't use the word end, whatever. So then we're going to have a start C, start R, end or finish C, finish R. So when we're drawing from 498.6 to 496.6, notice that this value here is going 498, 497, 496. So because that's going down, we would either need to figure out, okay, is it greater? Is it less than? If it's one way or the other, then we need to like increment or decrement until we find our way to the other point. Instead, we can call sort on our segment and get back the points in order. That way we can just create ranges from start R to finish R, and then start column to finish column, and we can build up our grid this way. Okay, and let's take a look at what that looks like now. If we run this, let's see why that isn't working. So yeah, so negative 490 is definitely not on the grid. So min R, max R, min C, max C. Min R, max R, min C, max C. And then our start and finish, I got these backwards here. Okay, so let's see if this works. There we go. All right, so now we're drawing the walls on the grid, and that starts to look like the example output here. So that's looking really good. Now, sand is going to be produced 1 unit at a time, and the unit is going to be dropped in at the top at the point 500, 0, and then it's going to fall down until it hits a wall or some other sand or whatever. And so what we need to figure out is, can the sand go down 1 step directly below it? Or if it hits, or if it's blocked, then it can try to go to the left, down into the left. And if that's blocked, it's going to try to go down into the right. And if that's blocked, then we are going to come to a rest. And so it's going to look something like this, where like this is the first grain of sand that was dropped from here, fell all the way down to here. It couldn't go down to the left. It couldn't go down to the right. And it was blocked. So it comes to a rest at that point. So let's make a new method here called pour sand. And that's going to take in our grid. And it's also going to take in the entry point of the sand. And so here we're going to pop off our row and column from the entry point. Then we need to figure out how to loop. So let's say that we have not come to a rest. So while we haven't come to rest, now what we want to do is we want to increment C and work our way down the grid. So if we want to basically say C plus equals 1 until we come to rest. So if the grid at C plus 1 R is equal to air, then increment C and just keep going until you hit the bottom, and then we're going to return grid at the end. Okay, so let's try calling pour sand for the grid at 0.500, and then I guess at the end, before we return the grid, we want to say grid at CR is equal to O, and that'll represent our sand. Okay, so let's run this again. And we should, okay, so now we're in like an infinite loop, right? So if we don't come to rest, okay, so then we want to say something like, otherwise, if that equals the pound sign, then rest equals true. We'll set, that means that we have come to rest, right? While we're pouring the sand, we also need to know where the boundaries are so that we can reconstrain our C and R, because we're going to receive the entry point as 500, but our index is like removing the minimum row and column. So here we also need to do, we want to do C plus 1 minus C min. And so this is going to be like, yep. And then R minus R min. So everywhere that we're working with row and column, we need to now remove the excess sort of around us. So now we're going to say grid at C minus C min, R minus R min should be that. Okay, pour sand, wrong number of arguments. We're going to pass in our bounds. And when we run this, undefined local variable or method C, it should be called min C, which is good. I didn't like saying C min. Okay. All right. Okay, now we have our sand falling all the way down to the bottom. That's great. Let's try pouring another grain of sand. We're going to use the same entry point and let's see where it lands. We'll run it and we don't get any response. That's because as it was falling down, it found an O, and the O is neither air nor a wall. And so it wasn't sure what to do. So if we get to a point where we find an O, then we either want to go like left or right. And I think this is going to be true for the pound sign too. So if we find an O, then we want to go try the left, and then we want to try the right. And so trying left is something like if the current grid is, so this is C plus 1 minus min C. So C plus 1 minus min C, R minus 1 minus R. So that should be to the left. And if that's a period, then we will say R minus equals 1 and C plus equals 1. Otherwise, if we go to the right, so this is us going to the right, then we want to do R plus equals 1 and C plus equals 1. So I think this should get us going to the left and to the right. So we'll run this again, and we correctly went to the left. That's good. Now let's try pouring another grain of sand, and this should end us, or this should drop us to the right. And it did go to the right. Okay, that's fantastic. Let's see what this one does. Okay, so this is crashing because now it's encountering a case where it sees an O below. It can't go to the left. It can't go to the right. And so we need some way to break here. So then I think what we want to do is say if this, else if this, else rest is equal to true. And that should break us out of our loop. Let's see. Okay, so now we have this settling on top. Great. So let's run this once more. All right, that is what we should have after 5 grains of sand are dropped. So if we look down here, this is what we have after 5 grains of sand. After 22 units of sand, it should look like this. So let's come back over here and we'll just say 22 times we want to pour a grain of sand. And that's looking really good. Okay, now after 2 more units come to rest, we're going to have one that drops there and one that drops there. So let's run this for 24. And this doesn't actually look right, okay? We're piling up on top of the left and right here, but those should have fallen off down below. We need to consider the case that there is a wall with a space to the left or the right. So this case here, actually, I think we want to merge that in with this case up here. So if it's an O or it's a wall, we want to try the left and try the right. And we're still going to come to rest. Okay, there we go. There we go. So now as it was falling down here, it said, okay, can we go here? No. Can we go here? Yes. Is there a way to go to the left or to the right? There was to go to the left, and then it came falling down here, and then it couldn't go to the left anymore. Then we dropped another grain and it fell here, then here, then here, then here, then here. So that is exactly what we should get after 24 units of sand have fallen. And now it says once all 24 units of sand have come to a rest, all the further sand pieces are going to fall like off of the edge over here. And so what we want to do is try, so if we tried to pour sand one more time for that exact same position and ran it, now we get an exception. And so the way I solved this was actually just to say count is equal to 0 while true. We're going to pour some sand and we're going to increment count plus equals 1 to count the grains of sand that are coming out. And then we're also just going to print out the count as we go. And eventually we're going to hit an exception just like that one, and we should crash. So that just gives us a number 24, which is the answer for part 1. I know it's crashing, but like we're using that crash as like our terminal case. And so if we grab our puzzle input, paste it in, let's modify our execution here so that instead of using this input, it uses input is file.read argv.first chomp true And we'll execute this against day 14 input. And we get 592. And 592 was part 1. That's the answer to part 1. Okay, in part 2, we realize that it's not just an infinite abyss below this line here. Instead, 2 layers down, there is a floor. And the floor goes infinitely in both directions, left and right. And so now what we want to do is we want to stack up all of the sand until it reaches the top where like the entry point is. And so this is actually fun. So what we want to do is here's how we're going to make a change. First of all, in our boundary check, instead of returning row and max column, our max column is now going to be like whatever it was plus 2 at least. Okay, now if we run against the example input, we'll see 24. Let's also look at, so that exception is being raised. So let's actually check the bounds as we're falling down and make sure that they're valid. So we'll check to see if R is between the min R and max R. And if it's not, we'll raise hell. I don't know. Okay, so here we did get this exception. So we got a runtime error of hell, so we raised hell. But we don't actually want to use raise, or we don't want to use the raise and except, like the try catch mechanism, for any control flow. Instead, what we want to do is use this concept called throw. So here I'm going to say throw done, as if we reached some terminal state. And then down here, I'm going to wrap my counter in a catch done do, so that when catch is thrown, or when done is thrown, we can handle that successfully and then continue and print out the rest here. So p count, we'll move count up here. Okay, so we're hitting this terminal state too early. Oh, so we want this to only throw if we're not between. Okay, so now we get down to our answer 24, and we did populate all of this. Notice that we now actually also have 2 new rows at the bottom. And as we're constructing our grid, in order to add the floor, or that bottom layer, we want to mark that all as a giant wall, which is going to be like the floor, right? So this is a floor. Okay, the next step in part 2 is that we want to use simulating that we're dropping sand until it reaches that top point. And so if we just start or continue pouring sand, as it stands right now, it ends up on the edges of that boundary. And so if we go look at our bounds here and we add some, I don't know, some fixed constant to like our margin, let's say that our margin is like 30 or something. So then we're going to have min R minus margin, max R plus margin. And that should give us like more space to work with on the bottom. Okay, but now our count is going way too high. So let's make this a little bit smaller. We'll say this is 3. Okay, so this did add the margin, and we are able to go off a little bit further. So let's say, I don't know, 10. So I noticed a bug in pour sand here. So if we see air, we're incrementing C+1, but that's going to like skip down a level if we don't have an else if here. So we were saying basically we're like expediting our skipping down. So that's one bug. Let's see if that helps us. Okay, so that helped us terminate a little faster. Let's change our margin now to 10. Okay, so it's still going infinitely. So this is our like infinite loop here, is while it's like inside of our pour sand. So what I'm going to do is add by bug, and inside of our loop here we'll just drop in by bug. Okay, so let's actually move by bug. Let's move by bug into this case where we know that it's not a period anymore. Okay, so in this case, what are we looking at? All right, so we found the floor, puts C and R, So we're at 508. So that means that we have found this position here. So if that's correct, that's going to be, okay, so that is a pound sign. So this is not going to match. This is not going to match. And we're going to come to rest. And then we should have grid at this position should be marked as O. If we display the grid, then we have our O that dropped down into that position. Okay. So let's run continue a few times. Display the grid. Okay, so this is like how it's looking now. So let's actually move ByBug down to this grid point here. And I want to display grid and then see ByBug. That way we can step through as the sand is falling. Okay, so there's our first point. Second point. Okay, so this is as the sand is falling down. That's pretty cool. All right, that's the 24th, 25th, 26, 27, 28. Okay, so it's building up. And it looks like it's building up correctly. Okay, so then you can also see like how many grains of sand have fallen. So we're at 78 and we're still dropping sand. It's falling down the right side. And then when we get to the number 93, it filled in the top point there. But now as we're dropping more grains of sand, I think they're just ending up on top of themselves. Like we don't have an end point. I think this is actually working as expected. We need another throw if we've completely filled the sand. So if the grid at the entry point is marked, then we need to throw done. If CR equals entry. And then we're going to return, let's see if this works. Okay, it's filling. I should have just removed ByBug, huh? Okay, so we're at 92. So puts CR, puts entry. Oh, it's backwards. Okay, so this should be RC. And we're going to remove ByBug, quit, run it again. Boom. All right, so this is totally working. So we see the number 92. We know that it's one more than that, or we know that's like the answer is one more than that, right? So 93 units have come to rest. Now what we need to do is run it against our input. And it populated a bunch of really cool images here. And we get 3159, so it should be, oh, nope, that's way off. Okay, so part of the problem is that even if we like zoom way out, you'll notice that part of the structure is like ending up on the edge here. So it's not actually able to like completely fill out the margins. So what I want to do now is our margin constant so that we can fill in those edges really far. So let's make the margin constant, I don't know, 500, and then we'll run this again. And let's actually not display the grid every time because that is really hard to read. And we'll remove this one. And if we run it, okay, 30,366 plus 1 is 30,367. Whew. So this was a toughie. The solution is definitely not elegant. I am not a huge fan of all of this nasty if then that with all of this different math that's happening inside of the grid coordinates. I guess we could have said, okay, let's grab next level C. Next C is going to be C plus 1 minus min C, and then we could have used NC in all of these cases, okay? And then R minus min R. I guess this is also NC, and then R minus min R. So then NR is R minus min R, and R, and R. This one is going to be different because it has -1, and there's another one that's +1. So this is going to be NR minus 1, and this one is going to be NR plus 1. Okay, so that cleans it up just a little bit, but still I'm not a huge fan. Okay, that should still work as expected. The other thing is that, yeah, just working through all of this is so nasty, kind of building up all of these grids and figuring out our boundaries was rough. There's just like a lot of nastiness in this example, but we did talk about heredocs. We also looked at throw and catch. So throw and catch is an interesting control structure that you can use instead of throwing or raising an exception and then like catching that exception with except. You can use throw and catch as a way to like break out of things. So this was an interesting use case for that. Remember, as we progress and get closer to Christmas, they're going to get harder and harder. So this one was a little bit tougher. And yeah, I'm curious to see what we have in store for tomorrow. Thanks again, and we'll see you next time.